All right, I think we are now officially streaming the first Nirmata office hours for Kyverno Live. At least I hope we are. So with that, welcome everybody. Those who might be attending in viewer mode. This is the Nirmata office hours for Kyverno. And please take a look at the notes section if you are a member of the distribution grid list, you should have received an invite for this, and we have posted a notes section. So today is March 9th, 2023, and we are going to talk about testing with the Kyverno CLI. And if you have any questions, this is intended to be fully interactive. So please do, either if you're joining us live, in participation mode, please unmute yourself and give us a shout or put a comment in chat, and we would love to address it. So with that said, let's just flip over and take a look at the Kyverno CLI. So let's start with the beginning. So the Kyverno CLI is a separate utility that we publish that allows testing of Kyverno policies. And here's the website that covers the Kyverno CLI. It allows testing of policies and things like a CI/CD pipeline so that you can know and understand what the behavior of your policies are going to be before you install them in a cluster. And it has several different pieces of functionality, but the two main ones that that are used for this purpose, there's a test command and there's an apply command. And so we'll start with the apply command. And the apply command here is used to take a given policy and apply a resource to that policy and see what the result is. This is probably the most common one that's used in a pipeline because you don't necessarily know or have the resources. You just have a policy and you want to know the disposition of those resources when compared to the policy. So an apply command can be used, and you can see here, it's just a simple Kyverno apply, and you add the policy, and then you add the resource. And once you do that, you'll get a result that's spit out to tell you what that looks like. And in a case of a validate policy, it'll tell you whether it passed or it failed. If it's a mutate policy, it'll show you the result of the mutation. So this can be useful to just check and make sure, again, before even putting it in a dev or test cluster, that the mutation is going to happen as you expect it'll happen. You can also do things like getting the resources from a live cluster. So you can, before you install Kyverno, you can get the resources that are actually in that cluster and check and see what the results would be against a policy or even a path to a bunch of different policies, which can be very handy so that you don't have to do things like copy and paste resources to YAML manifest just to pass them like you see here in the above command. You can just pass the cluster flag and be able to harvest those resources from the cluster. You can also pass those resources from standard in. So you can do things like use customize to build from your overlays and then apply those through a pipe through the Kyverno apply command. So that can also be super handy. And if you have variables, those variables, if you're using it in cluster mode, so with this cluster flag, the variables should, I believe, be picked up from those that are in the cluster. But if you need to pass them manually, then you can also do that as well. So we'll just flip over and take a quick look at this here. So I'm looking at the Kyverno policies repo, and let me actually just show this up here. We have a whole bunch of policies that have test cases, which we'll get to in just a minute. But I'm looking at the Kyverno policies repo, and inside of each of these folders, and you might recognize these because these are the same ones that are available on the website. In each of these folders, we have test cases, but in each of the test cases, we have resources that can be used for this testing. And we'll get to the test command a little bit later, but this is an example of something you can just go and pick resources and try them in your own environment with the apply command. So let's just give this a shot real quick. So I'm looking at the require labels policy, and let's just take a look at this policy real quick. So this is a very simple Kyverno policy that's going to check any pod, and it's going to check for the label app.kubernetes.io/name. And of course, you can customize this however you like, but this is what's currently available on the website. We're looking at the policies that are in that policy repo that I just showed a minute ago. So what we want to do is test a resource, and you can see the name of this one here is bad pod. I'm just going to temporarily create a temp file and just isolate this one just to show this policy that's in action. So it'll get the policy here, and then we're already in this directory. So we will do, and I have Kyverno CLI installed as a crew plugin. So actually that's a good idea. Why don't we backtrack just a little bit and talk about how you can actually get the Kyverno CLI. So Kyverno CLI is a Go binary that's available on the releases page for Kyverno, but we also have a number of other ways that you can install it. One of the most popular ones seems to be with crew, and it's just as simple as doing kube control crew install Kyverno if you have crew installed. And for those who may not know, crew is a plugin system for kube control that allows you to access a whole bunch of different community and project capabilities that are, in most cases, standalone binaries, but can also be shell scripts that kube control can then run. And so since Kyverno CLI is a binary, we have that working for crew. So you can just do kube control crew install Kyverno and be able to run Kyverno from a kube control command. They have some other ones that are available here. You can get it through Homebrew. That also seems to be pretty popular. If you wanted to just get it manually from the releases page, here's a command that allows you to do that. And of course, you can also build the CLI directly from the source if you like. And we have builds for all the main architectures, including ARM64 at this point in time. So that's how you get the CLI. And right now the current release is 1.9, and so that's what I have installed. So let's just double check. And so my K command here, I have K as an alias for kube control. So I'm just doing basically kube control Kyverno because I have this as a crew plugin. So let's try this with the apply command. So we'll do K Kyverno apply, and we'll pass the policy, and we'll do a resource temp. All right, and so we can see very simply here, here's the output that we got. So it's applying one of the policies to one resource, and here's the result of that. So it told us here that the validation failed, and there's our message that's in the policy. And at the very bottom, we can see if we're passing multiple ones, we can see what the result of this is. Now, we see the fail one, which is what we expect for a pod, but the skip two, it's actually because Kyverno has this neat ability called autogen, which allows Kyverno to generate policies for other pod level controllers without you having to do anything else. So the skip two there refers to that the autogen has kicked in, and this pod's not applicable to them, so it's being skipped. But the rule, which is the main rule here, check for labels, is applicable, and that's where it surfaced in the fail portion. So that's basically the Kyverno apply command. You can get a whole lot more fancy with it. Let's try and apply the whole resources file to it. Resource.yaml. And so you can see at the bottom, it picked up all the resources that were in there. So I just created temp a moment ago to just isolate the first one, but you can see when passing a file with multiple resources in it, it gives us a combined score. So 2 of those passed and 2 of those failed. And then on the skip, the reason why that number is 8 is again because of the autogen rules and also the resources that are being compared to those autogen rules. So in this case, a total of 8 were skipped. So that's the apply command. And there's a whole lot more that you can do with it. But actually, let's apply this to my cluster that I have. So I'm running a K3D cluster that's here. And I have a whole bunch of pods that are running. And so let's see what happens if we apply the same policy to this cluster. All right, so now you see Kyverno going nuts, picking up my kube config, and then testing all of the pods, because that's the source of the rule here in the cluster. So now you can see very quickly and easily a full result of that policy against all the resources in your cluster. So you have a pretty good idea without installing this policy in the cluster. And I don't have the policy installed. So no resources are installed when I'm getting cluster policies. I don't have this policy installed, yet I was still able to know, based on this policy, what the results might be if I installed it in a cluster. So if I were to install this policy in the cluster, right now it's in audit mode, which means that policy reports are going to be generated. And if we were able to create this policy, we would see the equivalent of this in policy reports. So we'd see a number of pass, a number fail, and also a number of skip. And so that is the Kyverno apply command in a nutshell. Any questions that we've gotten on this so far? And just so some of the other things that you can do with this, so you can apply a bunch of policies to it. I believe it also supports, I think it also supports Git. I think you can also pass a Git repo of policies and maybe resources to the apply command.
Yeah, I'm pretty sure you can do that for policies. Not sure if that also works with resources.
Okay. So let's take a look at, so that was require labels. Let's see if we can do, let's find a mutate one. Add certificate volume. The mutate. Yeah, let's try this one. Okay, so we have a policy here. Let me get out of this. So let's try this against a mutate rule. So in this case, we're going to match on pods, and we're going to inject into the pod a couple things. A container, or sorry, we're going to inject a volume, and we're going to inject a volume mount into every container. And this is actually a pretty useful policy because you can do things like injecting certificates or other things that you might want as a volume. And so Kyverno can do this pretty simply as shown here. So let's just again walk through it a little bit. So this is a cluster policy. It's going to apply across the entire cluster. We are not going to consider the higher level resources. So I talked a minute ago about Kyverno having these autogen rules, and that's great. And sometimes you need to control the scope of that. So in this case, we really only want to mutate pods directly and not their controllers. And so if you wanted to control that autogen behavior, which is what this rule is doing, we're just simply saying, disable the ability to generate those autogen rules on daemon sets, deployments, jobs, and stateful sets. Now, there are cases where you want to have that intact, but in this case, we really just want to mutate the pods directly. So the net effect may be if you're creating a deployment, Kyverno's not going to mutate the deployment, but it is going to mutate the pods that are emitted from the deployment. And since this happens after the pods are created, there's really no reconciliation war because the controller believes that it created pods according to the template, but Kyverno mutated those pods to add this additional information. So in some cases, you may want to do that. In other cases, you may not want to do that. For example, if you want to have alignment between your deployments, for example, and your pods, you probably don't want to do this. You probably want to perform the mutation at the deployment level so that when you see a deployment, you know that the pods that are emitted by that deployment are going to be consistent. But in any case, that's what this is done. That's what this rule does, because there are use cases where you want to do that. And so we're matching on pods. And then we're using a precondition section here. And we're saying we need all of these things to be true before proceeding. So we're looking for an annotation called inject-certs, and it needs to be equal to the value of enabled. So if that annotation is present in a pod, then it'll pass this one expression. And you can see, for those maybe who are newcomers that want to kind of just check this out, Kyverno uses standard Kubernetes style tripartite expressions, key operator value. You're already familiar with these. Kubernetes uses these in a lot of different places, like taints and tolerations, and other places like I think topology spread constraints, a lot of different places. So Kyverno picks that same concept up and reuses it to make a lot of the fine-grained decision that you can really get to scope down the behavior of a policy. So this is the first one we're checking for. We're checking for that annotation. And the second one we're checking for is that the pod is being created or updated. So if either one of these is happening and this is true, then it's going to go and mutate the pod. And what we're doing here is we're looping through all of the containers, and we're going to add to each container a volume mount. And then to the pod spec itself, we're going to add the volume. So we need to add the volume to the pod spec, and then we can go into each container and we can mount that volume. So that's what we're doing here. And we're going to pick up from a config map named ca-pimstore. Now, in this case, with testing it, that's not going to exist. We don't need it to exist. But just so you're aware, this is what the policy is supposed to do. So if we look at a resource and we just have a basic pod here, we do have that annotation set. And we are going to attempt to create this, at least mock it as a creation through the CLI. And so using the apply command, we should be able to see the result of this mutation. So let's try this. And so there you go. So we use the apply command to apply the policy, and then we pass that resource that we just saw. So it's applying one policy to one resource. And then you can see here is the result of the mutation that Kyverno would make. So it passed, and there's the result of it. So this can be, again, really handy to use in the policy development process and also the testing process, because you can do things like pipe this, for example, to a file, send it to a file, and then check that file or send that file to do something else with it. So that is the apply command. We looked at both a validation and also now a mutation. So hopefully that kind of makes sense and at least gives you some ideas on how you can use it. And actually, let's flip back over to the docs, because on that point of using it, we actually have a sample GitHub action, and I'm trying to remember where it is, that shows how you can use this and gives you a sample that you can plug in immediately. I think it's here. Yep. So over on the testing policies page, and if you haven't looked at the Kyverno docs, highly recommend going and checking these out. Got a whole section on CI. And obviously, there's a lot of different CI tools that are out there. Kyverno can work with all of them. It doesn't really matter. It's just a binary that you run. But we do have an action here for GitHub. So if you're using GitHub Actions, which is a pretty popular CI system, we use it internally in the Kyverno project. Here's an example action that we provide that shows you not only the structure of what we'd be working with, but how to actually use the apply command in your own environment. And so you can see right here, this is what we're doing in this sample action. So we're downloading the CLI, and then we're just basically doing what I already showed. We're running the apply command, and we're applying the whatever resources are in the resources folder to whatever policies are in the policies folder. You can also test your predefined test cases, which we'll get to in the next segment here, because we'll look at the test command. So anyhow, here's an action that you can use right now to help expedite the process of getting up and running with the Kyverno CLI and doing things like applying resources to policies or testing them. And if you wanted to check out how this actually works, we do this as part of our own CI process. So whenever new policies are being submitted to the policies repo, we have test cases that run to make sure that those tests actually pass. This screenshot's not from that run. This is an example run of what you might see if you plumbed this into your own repo, but you get the idea. And if you did want to see some of those example runs, you can just go to the Kyverno policies repo. It's of course public, and then take a look at the actions, and you can see where we're running the CLI ourselves in each of the PRs that get sent to it. And so if you, in the case of the apply command, and let me zoom in a little bit here, a little bit more. I guess it's still kind of barely visible, but if you were running this in your CI pipeline, there's nothing else that you need to do to know if results fail. It'll exit appropriately and fail your pipeline. So here's an example of what happens if you run that apply command in this case, again, GitHub Actions, but it doesn't matter. It's going to fail the pipeline. So you're going to know immediately if someone submits a resource and it fails a policy, then you're going to know about that. So this is probably the most common one if you are going to use the Kyverno CLI in your, in shifting left in your processes, and we do recommend that you do that. This is probably the first command that you're going to use. You're going to have a set of policies that you want to ensure your resources that your users submit adhere to, and you're going to use the apply command against those specific policies, and then do things like checking PRs, where a PR is going to have some of these resource manifests in them against those predefined policies. And so you'll know in the development process, long before they ever land in a cluster, should this PR be accepted or not, yes or no. You'll get some of that information here. And that can be really helpful for your users because they don't need to approach anybody, and they certainly don't need to attempt to deploy that manifest into a cluster and see that it fails before going and modifying it. They can get that feedback quickly in the development process, and also be able to see from the output which policy that failed and why it failed the policy. So that's the apply command. Any questions or comments out there on that? I'm not seeing anything in the chat. And of course, any of the other folks, if you're, I can't remember on the live stream if we're able, if we have questions that come in there, but if we do, feel free to shout them out. Anybody want to take the test command, or should I just keep rolling here? I'll take that as I'll keep on rolling then.
Yeah, I guess you could go ahead.
Okay. All right. So the second one here is the test command. So again, more documentation on the test, but in a nutshell, the test command is used to check a predefined set of results against policies and resources. So it's probably best to just show this, what this looks like. Let's go back to the best practices here. Let me close this. Let's go back to our require labels command or policy. So here's an example of a Kyverno test manifest, and you'll notice that this is a new thing. We didn't talk about this in the apply command because this isn't something that you need in the apply command. In the apply command, you have policies, those are known, but you don't have resources, those are unknown. So you want to know the result of the unknown. The test command is a little bit different. You do know what the result that you expect is. And the way that you do that is by writing this Kyverno-test manifest. And in that, you define the policies that you want to check and the resources that you have, and you define the result that you expect for each one of those things. So in this case, we're looking for a resource that's supposed to be found in this file called badpod01, and we expect that this pod is going to fail the policy and rule. So rules are contained within policies. We expect that this is going to fail. We want it to fail. We know that it should fail. And this is important because in testing, you need to test positive and also negative cases to get a full picture of the efficacy of a policy. And this will help you write effective policies and make sure that users or processes that maybe are able to do things that they shouldn't be able to do are in fact not able to do them. And so you can see that we have some fail cases and we have some pass cases. And so the Kyverno test command, unlike the apply command, is used to validate that you're actually getting these results. And this can be useful when you're doing things like preparing for a Kyverno upgrade, or you're making modifications to a policy that you already have deployed out in your cluster, for example. There can be a lot of reasons why that you want to check and validate that the result is what you expect prior to allowing those changes to occur. So this can be a really useful thing. And so kind of covered how this worked, but let's actually see this in action. So before that, let's go back and take a look at the require labels policy here. So again, we're just checking for app.kubernetes.io/name, and we're going to delete the temp file. Don't need this. We'll refer back to the resources. And let's get the test manifest open here. So in the test manifest, like I mentioned, you have to define the policies that you want to test, and you define the resource files that have the resources that apply to those policies that you want to test. And then you define results. And in the results, you specify a result for each one of those resources and what the result is. So like in the apply command, at the very end, you recall we saw an output of whether we were getting pass, fail, skip, etc. Well, those are the same results that we need to declare here, because we need to know the result that we actually got compared to the result that you said that we should get. If those are the same, then the overall result is pass. And so that's what the result here is, not necessarily whether it passed or failed the policy, but does the actual result match what you declare in this. So what we want to see, we want to see everything pass when we run the command. But the results here mean that if we see everything pass, then that means that the actual result is the expected result. So let's just take a look. Here's badpod01. It does not have the label. So we expect that this is going to fail. So if it does fail, we're going to see that the overall test case is going to show as a pass. So just make sure that when you're using this, that you have clearly separated in your mind the difference between declaring the result here and what the CLI is going to show. So maybe let me just shut up and test this because it's probably easier to show. So we'll do Kyverno test and then dot because we're in the directory. We've already got the manifests that are in here. And so as you can see, this table is going to show the full output of all the tests that were executed. So that's why I was saying in the result column, we expect everything to show as a pass. If you're seeing it as a pass, that means that the actual result matches the defined result in your test manifest that's here. And so if we were doing things like manipulating this policy, and maybe let's go and let's see, how could we modify this? We could probably change deployment here. And so if we were able to change the kind to match on deployment rather than pod, we don't have anything but pods in our test cases here. So our test results now don't match. You've said that this is a fail, but we're not able to see that that's a fail result. So overall, the test case has failed. So this can be useful, like I mentioned, if you want to trial some tests to your policies before you make those modifications in your cluster. And maybe you have, and you will need to have defined in your resources file or files, if you're using multiple, you'll need to have some example resources that you expect to have in your cluster. And typically these are things like maybe deployments of your own application that you're running. Like you have every cluster has one of these deployments. This could also be something like an ecosystem tool, like you have service mesh, or you have a monitoring, or you have a cert manager. Some of these basic tools that you have in your cluster, you want to make sure that those aren't disrupted. And so you can take some of those resources, put them into your resource file, and be able to write a test case to make sure that any policy modifications you're going to make don't have unintended consequences. So I change that back and just do a Kyverno test again. And seeing pass results. So that's basically the gist of the Kyverno test command. Now there's obviously more detail that we could get in here as far as policies that are more complex, that have variables. And let's actually just quickly show that, because most policies are going to have variables. And let me see if I can find an example. And here's an example of it here. So if you do have policies that have variables, you can pass a variables file to the test command, because if you think about it, when you're testing policies, you don't have a cluster, you don't have all of the runtime effect. Kyverno's not able to really understand what the values are going to be. In some cases it will, but in some cases from like admission review, like you don't necessarily know what the usernames or the groups, for example, are going to be. That's just simply not available. We can't infer that from the resource itself. And so if you do have such policies, you can define this variables file and pass that into your test case. And so we don't have one in this test case, because this is fairly simple. There's no variables that it uses. But if you did, then you would define a variables file and you'd define a variables key and then point to your variables file. And then that's what the CLI would use to be able to fully run a simulation on those resources to understand what the result's going to be. The other thing that the Kyverno test command can do, similar to the apply command, you saw that we demoed that on a validate policy and a mutate policy. Well, so too can the test command be used to check the results of a mutation and even a generated resource. And so if you're using a generate rule, then you can check with a patched resource. You can provide the file for that. And so this is a case for where I mentioned with the apply command, because the apply command can output to standard out the result of that mutation. You can take that and supply that as the patched resource and be able to check those results against your policy. So let's quickly do that and see what this looks like. Let's go back to, I think we have a test case for that. That was the same one that was in add certificate volume. Yep. So let's go back to add certificates volume. So I'll close all these and we'll go back to the same policy. So this is the one that we just showed in the test command. And here's the test manifest for it. Now we only have one test for this, but you can see that we're specifying the patched resource here, and we're calling this patched resource. So here's what that looks like. And so this should be familiar because this is basically what the output was from that Kyverno apply command. So if we go back in here, we should be able to run the test command on this and see that this did pass. And so the test command in this case is used to test a mutate policy against an expected result and compare that with the actual result. So if the actual mutation that we got matched what our patched resource file looks like, then the test passed, we're all good. So again, can be super helpful, not just for validation and not just for mutation, but for generation as well, looking at the actual result and see, is this supposed to be what I'm going to get? And so using this in addition to, or even separately, it's not like you have to use the test and apply commands together. They're separate commands. You can use these together to really get some pretty useful insights in your pipeline, in your policy development process for your users when they submit PRs, and also in the troubleshooting process. So generated resource, again, like I mentioned, you can pass a generated resource that's expected here. And I think we even have some tests of this one. Do we? Yeah, we do. So let's go to add network policy. Let me close all these down. All right, so here is a Kyverno generate policy. And for those that may not know, a Kyverno has the ability to, in addition to validating and mutating resources, Kyverno also has the ability to generate, i.e. create all new resources from a definition of your choosing. And so in this case, we have a generate policy, which is going to give us a network policy in any namespace that's created. So we're just matching on any namespace here. And it's going to generate for us a network policy called default deny. And you can see here, we're using a variable which corresponds to whatever the name of the namespace is. And it's going to generate a network policy that looks like this. So the shape of the network policy under spec is going to give us all this. So it's going to deny all the traffic that's in the namespace. Well, we can test for this in the Kyverno test command. So you saw in the docs that I was pointing to generated resource key, and there's the value of it. And this is our network policy. So we can use the test command to test an incoming resource. In this case, it's a namespace, hello world namespace. And what we expect to have is a generated resource that's defined here, look like this. And so in addition to the validation and mutation cases, you can also use the Kyverno CLI to test things like the result of a generation behavior, which can be super powerful if you're doing multi-tenancy. Now you can run these things in your own internal pipeline, not necessarily your tenant or your customer pipelines, to know that the system that you're providing, you're going to give them the same resources. So for things like t-shirt sizing, for example, is a popular use case when it comes to multi-tenancy or namespace as a service. If someone added a label, maybe this policy triggered on a label to give you a resource quota, and we do have a policy that gives you a resource quota right here. Maybe in addition to a namespace, you're matching on a label, and you want to make sure that in your test cases, that if they order a medium sized namespace, then you're getting a medium resource quota. So maybe this is an example of a medium resource quota. And if they pass a label value that's a large resource quota, they get a different one. So you can do things like checking this with the Kyverno CLI to not just know that, hey, yeah, I got a resource that was generated. That's cool, but what's it look like? Is it the same one that we expect? Well, that's what we can do here. So let's just test this real quick. And again, not changing the test command where we already have all the files that are co-located in this directory. So we'll just test it. And you can see it passed. The actual result was the same one that's in the generated resource. So let's change this a little bit. And let's say that in our generated resource, something happened, and I don't know, instead of under the policy types, instead of getting both ingress and egress, which would effectively lock this network policy down for that namespace, maybe we only got egress. So we would expect this to fail. And we, in fact, saw that this failed because the generated resource did not match what we specified ahead of time in our manifest here. So that is the test command. I guess we don't have any questions or comments around that. I think that's all. That's most of the test command. There's more stuff when it comes to things like if you're using namespace selector, you can pass those in a variable file. Things like user info, because like I mentioned, when you're testing, and actually this is a good point to note. So for both the apply command and the test command, do keep in mind if you're going to use these in your own environment, the Kyverno CLI doesn't know about the mutations that the Kubernetes controllers are going to do by default. The Kyverno CLI doesn't embed any of the Kubernetes control plane components. So you need to take that into consideration. And I believe we call that out in the docs, but just FYI, make sure that if you're testing something and it's showing that it's passing or maybe failing, that the resource that you're testing, you're accounting for the things that the Kubernetes controllers are going to do. So for example, if you're testing a pod, and let me flip back over and show an example of that in, let's see, the required labels. So actually, let's just demonstrate this in action for maybe those who aren't aware of the types of things that Kubernetes is going to do. So I'm going to, let me isolate this resource again. So this is the definition of a bad pod that I'm going to create. Let me change this to just some image so that I don't end up pulling an Nginx container. And we don't really care about pulling the image, but if this is your definition that you're testing or that you want to test, this is not what you're going to get at the end of the day when you run this resource in Kubernetes. So let me just see if I don't think I have any resources that are out there. Oh, and by the way, here's a nifty command that you can use. So all of the Kyverno resources we have in a group called Kyverno. So you can do things like kube control git Kyverno, and I'm passing the dash uppercase A to say, show me all of Kyverno's related resources. Don't care what they are, show them across the cluster. So this can be really handy in a lot of different cases. If you just want to see all of the things that are related to Kyverno in one command, you can just do a kube control git Kyverno. You don't have to do things like kube control git cpol for cluster policy or kube control git policy report. You can just do a kube control git Kyverno -A and get everything across the cluster. So with that said, just to illustrate the point of the types of things when you're testing and applying resources that you may get different results, here's a very simple pod spec. Now, there's not a whole lot defined here, but let's see the difference of creating this. So we created this. Now there's only 8 lines here, but it's pretty barren. But let's get this back. And I'm going to pass this to bat that I've got colorized so that we can get some nice info. Now take a look at the difference between this definition that we submitted and what the API server is going to hand us back. Look at all this stuff that we got here. So let me just point out specifically, you see we got a volume mount and we also got tolerations. Now this may be dependent upon whatever you're using your cluster. I'm using K3D here, so I may get some tolerations that you don't have. But we also got a volume down here, and this by default, because we are mounting the service account token, it gave us a volume and a volume mount. That wasn't anywhere in our definition. So just as a way to illustrate, when you're using the Kyverno CLI to test resources, regardless of whether it's with the apply, but specifically with the test command, you just want to keep in mind things like this. And these can be version dependent, by the way. Like one of the recent changes in Kubernetes as of the past, I think couple versions, was how service account tokens were consumed. So you just want to keep this in mind when you're developing these test resources. Make sure that you're providing the Kyverno CLI a realistic resource that's already undergone some of the default mutations that Kubernetes is going to apply by default before you factor in whether that passed or failed. So just a tip there. This may be known as far as the things that Kubernetes does, but in case you didn't know, now you know. Okay, so I think that's enough on anything else to add on the apply or test command. I'd like to show the JP and the OCI command really quick if we can, if there are no questions or discussions that folks want to have on the previous ones.
Yeah, no questions on the live stream, but just thinking that perhaps JP or James path is a good topic of its own, but maybe you can just quickly show that at least the command exists.
Yeah, we definitely should have a session just on James path.
Right.
But I'll just quickly cover the JP command. And actually, I realized that we need to update the docs on this because we had some recent, the JP command was recently restructured a bit. But let me just show quickly the JP command. So the JP command in the Kyverno CLI stands for James path, and James path is a system that Kyverno uses to parse JSON in a much more powerful way that unlocks a lot of the very specific capabilities that you can get when writing policies. So if you compared or considered a basic rule like require labels, there's no James path that's in this. We're using a standard, what we call pattern declaration, to just look at the field that we expect to be there. But for some of the other policies, and we showed that in the adding of the certificate volume, we're using some James path expressions here. And so this one, for example, is looking at the annotation, looking for an annotation called inject certs. And you notice that this is surrounded by these curly braces. Again, not going to get too much into James path, but this is the system that Kyverno uses in order to really get a lot of power out of being able to write these rules, but still do so in a pretty simplistic way. The CLI has the ability to leverage or check these James path commands when you're authoring a policy, which can be super helpful when knowing either troubleshooting something or just knowing that it's working properly. So there's a lot of different commands that are available here, but query is probably the one that you're going to use when it actually comes to testing those commands. And but another nice thing about this is Kyverno has a whole bunch of James path filters that are built into it that you won't find upstream or anywhere else, that we've written specifically for Kyverno to do even more powerful processing, but in a very simplistic way. And we can retrieve those with this function command. So if I do Kyverno JP function, and I think we just passed that. So you can see it's going to return all of these functions. And so here's a function called toLower, which, as the name implies, and also as the note states, it just takes in a string and outputs the same string with all lowercase letters. And we can actually use the Kyverno CLI to test not only these filters, but anything that's upstream in James Path, which can be a real boon for you when you're developing these policies. So just quickly, let's say if I wanted to test JP query, let's actually do, we need to send it some input. So we'll echo hello, and we'll do query to lower at. So the at symbol here just means take whatever we're getting from the input. In this case, we're getting it from standard in, we're piping it in, and apply that filter to it. And you can see here down at the bottom, the CLI used that filter to lower, and it gave us the output. So you can use this with any of the functions that are built in. You can see there's all sorts of custom functions that we have built into Kyverno. And if it's not obvious, these things aren't just found in the CLI, they're built into Kyverno itself. It's just that we also allow the ability to test and simulate these with the CLI. Super powerful things that you can do with the apply, test, and also JP command. But also one of the nice things, or just want to point out real quickly, that was added in Kyverno 1.9 is Kyverno now has experimental support for pushing and pulling Kyverno policies as OCI artifacts. And so if you have an OCI compliant registry, and basically all of them are at this point in time, you can use the CLI to push a policy into your own registry, which this is the first step of some other ones that we're going to be working on in the future. Ultimately, we want to be able to retrieve these in Kyverno itself, that is the in-cluster component. But for right now, the CLI gives you the ability to push and pull these to a registry. So let's see if I can show this here. So just the command here is fairly basic. So we want to push an image. So in this case, ghcr.io, the Acme organization, in the My Policies repo with a tag of 0.0.1 is going to push any policy where this is executed called require labels. And you can also push a whole directory of policies if you want to. And here's how to do that. And once you push that, you should be able to see that you now have an image that represents those Kyverno policies and be able to pull those with the same commands of Kyverno OCI pull from that image. And then it will then either give you the policies right there, or you can send them to a directory. So let's see if I can maybe very quickly show this. Hopefully this works. So let's see if I can push the require labels into my own GitHub image. So we'll do, oh, we also need to do the, since this is an experimental command, we do need to set this environment variable to 1. So we'll do K Kyverno OCI push I. All right, let's see if this is going to work. Okay, cool. So it pushed that to my registry, my GHCR registry with under my name. And so now if I were to go to, let's go to a separate directory so that we know that this is not here. Let's do the same command, but let's pull it. We'll pull back from that image. And there we go. So it should have given us the require labels, and it did. So yeah, there is the require labels policy that I just pushed to an OCI registry, and I just pulled it back. So you can see this can be super nice for adding your Kyverno policies to a registry as an OCI artifact. So with that, I see that we're out of time now. Any last questions or comments from anyone so far? Hopefully this has been useful.
Yeah, definitely good overview. I don't see any questions, so we can end the session.
Okay,
All right. Thank you.
thanks everyone.
Take care.
Thanks,
Bye.
Rip.